Okay, so an example for we're asked to find the horizontal and vertical asymptotes of the graph. We actually don't need a graphing calculator to tell the asymptotes in this particular case because we have limits. So what we're going to do is we're going to relate what is the interpretation of horizontal and vertical asymptotes in the limit context. Well, horizontal asymptotes, let's just remember how they look like graphically, is that particular line that my graph may or may not cross at some points, but it's actually the y value that my function takes whenever x grows very, very large. And the vertical asymptote is that particular value on the x axis for which my function either grows very, very large or actually gets very, very small or large negatively. So I can see that, for example, in the horizontal asymptote case, I'm interested in finding the limit as x approaches infinity of the function and as x approaches negative infinity. On the other hand, for vertical asymptotes, I'm interested in that value a for which the function is not defined and to see how it behaves from the left and from the right. So let's start with horizontal asymptotes for this example. If I have an algebraic fraction, remember that I have to find the highest power of x on the denominator and divide both sides, numerator and denominator, by that. So when I do that in this particular case, I notice that I have a square root. So the x actually cannot divide these two terms because both terms are under the root. So in some way I have to bring this x inside the root. So let's see how we do that. In our careers we have learned that a square root of 8 is 2 rad 2. And this is because 8 is 4 times 2. And then I do square root of 4 times square root of 2, and this gets simplified to 2 rad 2. So in some way we have brought the number 4 outside, but being outside the root means actually having to take the square root of that number. So this square root of 4 becomes 2. So if I wanted to bring a number, let's say I have 3 square root of 2. This is the same as 3 square root of 9 times the square root of 2, so this would be a square root of 18. So if I wanted to bring in some way 3 inside the square root, I just have to square it and it will be happening inside the square root. So the same idea here. If I want x to be inside a root, then I just have to square it, and that's how it would look like. And this is true as long as x is a positive number, because if I want to bring x knowing that it's negative, I have to do something different, because remember that whenever I square a value, doesn't matter if it's positive or negative, my answer is always positive. So bringing an x inside will make my root be negative, be non-negative anymore, so I have to fix that, but we will talk about that later. So in here I can bring the x squared, and this is what you see in the book as well. I have 2x squared plus 1 over x squared, and this simplifies as 3 minus 5 over x. So when I do that, this distributes, so this is what I have at the end. Limit as x approaches infinity of the square root of 2 plus 1 over x squared, and the denominator hasn't changed. So again, I can calculate the limit of a square root of some expression, because one of the properties of limits is that it allows me to do that. The limit of a square root is the square root of the limit. So I know that this will be 0 from previous theorems, and this will be 0, so my answer here is rad 2 over 3. So that means that there is a horizontal asymptote at y equals rad 2 over 3. Now I just have to actually find the other limit as x approaches negative infinity, because we may or may not have another vertical asymptote. So it is the same function, it doesn't change at all. And the second step is the same, but when I'm bringing the x inside the root, I have to leave a negative out to compensate, because x is approaching negative infinity. This fraction I mean, when I divide by a negative number here and here, so both have to be the opposite of that. Therefore, this will be negative of the square root of 2x squared plus 1 over x squared. I think in the book it makes a reference to having square root of x squared. This is absolute value of x rather than just simply x. So because I know that x is negative, and I want it, when it's outside the root, I want it to still be negative, so my answer will become negative absolute value square root of x. So that's how I'm compensating for that sign. So again, this limit is very similar to that one, but instead of having rad 2 over 3, it will be negative rad 2 over 3. And that's it. I have my two horizontal asymptotes. One is here, and the other one will be y equals negative square root of 2 over 3. Now let's talk about the vertical asymptotes. What would be that particular value of interest? I just have to make my denominator 0. So if I do that, 3x minus 5 equals 0, so x is 5/3. So I'm finding my vertical asymptotes. Now I just have to make sure that this is actually an asymptote and not a hole. So I find the limit as x approaches 5/3 from the left of that function. And then I find the limit as x approaches 5/3 from the right of that function. Now, this is just a little bit of number sense. When I replace 5/3 here, 5/3 squared is a number, times 2 it will be a larger number, plus 1 it will be a larger number, and the square root of that would be a number. I know that this will not be 0, and when x is 5/3 in here will be 0, so I'm going to have a number divided by 0. So this is okay. I know that this is going to be some kind of infinity. Now I just have to determine if it's going to be a positive one or a negative one. So a square root of any number is always positive, so the top is always positive in this case. And now the denominator, I just have to make sure that I pick the right sign. If I'm to the left of 5/3, then the product 3 times 5/3. For a number less than 5/3, this is going to be less than 5. So if I have a number less than 5 minus 5, I know that's going to be less than 0. So the bottom is going to be negative. Therefore, this limit will be negative infinity. Now, on the other hand, when I'm on the right of 5/3, the product 3 times 5/3 will be a bigger number than 5. When I take away 5, this answer will be bigger than 0. So the denominator is positive now in this case, and positive over positive gives me a positive value. So this limit will be positive as well. Please don't show these pluses and signs. This is what should be going in your head. So now I know that this is a vertical asymptote, and not only that, but I know how the function behaves around. So I have a horizontal asymptote at rad 2 over 3, at a negative rad 2 over 3, and at 5/3 I know the function has a vertical asymptote. Vertical asymptote here, and I know that it approaches negative infinity from the left, so I don't know, it goes like this, and then to the right of 5/3 it goes like that. So I know how this graph sort of behaves around that asymptote. Now graphically, let's see, I'm going to turn off my previous graph, and then I'm going to turn this one on. So you see that's the first asymptote and the second asymptote. So I know that it behaves like this, and then it behaves like this. So now I can complete my graph with the help of my graphing calculator, but I understand what's going on in here.